All right, question number 5. As concrete cures, it gains strength. Data are in a file, and it gives, what does it say? 7-day and 28-day strength of concrete in pounds per square inch of a certain type of concrete. And we are asked to obtain a fitted line plot, so this is a regression, to predict the 28-day strength from the 7-day strength. Comment on what you see. And as usual, we're asked to get the residual standard deviation, the R-squared, check the assumptions, check the significance of the regression, and if I scroll down here, calculate a confidence interval on the slope, and then we're asked to get an estimated mean strength and a strength for one sample. So, all right, all of this can be done through the regression. So going to Minitab, we have our data here. So the concrete's poured, you measure its strength at 7 days, and you measure its strength again at 28 days. And we're trying to predict the 28-day strength of the concrete from the strength it had at 7 days. So stat, regression, fitted line plot first of all. So we are trying to predict the 28-day strength from the 7-day strength. And we're looking for a linear relationship, and because we need to check the residuals, we will ask for a 4 and 1. All right, my 4 and 1 at first glance looks pretty good. That looks pretty normal. This looks like a random scatter, so I'm going to call that one okay, and I will put that in the Word file afterwards, but it certainly looks like our conditions have been met, or our assumptions have been met. And when we look at this relationship, yeah, it looks pretty linear. As 7-day strength increases, so too does the 28-day strength. This is done in pounds per square inch for both of these. I got a bit of scatter here for sure around the line, but it's clear that it's pretty linear. The standard deviation is 271. That's my residual standard deviation. What is it telling me? It's telling me that on the average, the points deviate in the y direction from the line of best fit by 271 pounds per square inch. The R-squared value is 57.5%. What does that tell me? That roughly 58% of the 28-day strength can be explained by the strength that it has at 7 days, which leaves me with approximately 42% that's not explained, and that might have to do with the curing temperatures and whatever other factors you might be considering if you are pouring concrete. All right, I'll bring that one into Minitab. Now, the other thing, or not in Minitab, into Word. The other thing that we are asked in this question, let's go back here for a moment. So I just talked about A, B, C, D. We're asked to test whether a significant linear relationship exists and to check it at a significance of 0.05. And then down here in F, we're asked to get a confidence interval on the slope. Well, all right, really what all this means is that we need to run this from the second regression window because we need some information on the slope. All right, fit regression model. The y-axis is 28-day strength based on 7-day. And I'm not going to do anything else here. I'm just going to say OK. And this really is the information that I'm interested in right here, the coefficients. And I have my regression equation, but I kind of already have that from the fitted line plot. Okay, come on, let's go. All right, so let's plug that in right here. All right, with this information, what can we say? All right, this is what we're interested in. The p-value, for the slope of this regression line right here, that's what we're interested in. Now, in terms of the linear relationship, test whether there's a significant linear relationship. The null hypothesis, and anytime you see a p-value, there had to have been a hypothesis run. The null hypothesis is that the true slope of this entire population, this relationship, is equal to 0, meaning no significant relationship, if it turns out to be that, versus the HA is always, at least for Minitab, going to be that the slope is something other than 0. Could be positive, could be negative. So there is a significant relationship. All right, we were asked to make a decision at an alpha of 0.05. So I got that right here. And I'm simply interested now in the value of my p. So is p less than my level of significance? And the answer is yes, because my p-value is 0.011. And if that's yes, I reject HA, and what am I concluding? Yes, there is a significant linear relationship between these variables. So that's good, because if this had said that there wasn't, well, there wouldn't be much point in going on. Alright, so we have a significant linear relationship. That's good. And then right here we are asked to get a 95% confidence interval. Well, this is done the same way as what I did up in the question up above, and I'm just going to copy and paste that. So hold your horses right here. That's what I want. Okay, confidence interval. Now, in order to get the confidence interval, I need to know my slope, my standard error, and I need a t-value that is going to come out of a table or that I get from Minitab, one way or the other. Now, what do I know here? I know that my slope is 0.676. There it is there in my equation, and here it is. Alright, so that's 0.676. And the standard error of the slope is 0.206. Alright, so I got that bit of information. And the other thing I'm going to need to know here, I'm going to go back to Minitab. How many data points have we got here? And there are 10. So, alright, 10. And you always lose a degree of freedom for the x and 1 for the y. So it's going to be 10 minus 2 gets me 8 degrees of freedom. So if I use Minitab to help me get the t-value, so probability distribution plot, view my probability, I want to use the t, and I want to know what value is going to cut me off an area for 8 degrees of freedom. Now, we're asked to get a 95% confidence interval, so area under curve will be 0.05, and I want that area divided into the two tail areas. And Minitab is telling us that the t-value is going to be plus or minus 2.306. So that's the value I got to use in the calculation. So coming back to my Word file and plugging all this mess in. Alright, hang on, I'm going to do it and come back. Alright, I plugged in the values. That was the slope of our equation, the 0.676. The t-value I got in a Minitab was 2.306. Excuse me, and the standard error was 0.206. So if we work it out, we get this interval right here. And what does this mean? Now remember that slope is equal to rise over run. And in our case, we have the 28-day strength on the y-axis, and we got the 7-day strength on the x-axis. So what this really means is that we are 95% confident that for every, and these are done in PSI, pounds per square inch, for every 1 PSI increase in 7-day strength of this concrete, the 28-day strength increases, because this thing got a positive slope, increases by 0.201 psi to possibly 1.151 psi. Okay, so there we have that one. And then we're asked, what is the estimated mean 28-day strength of this concrete if the 7-day strength is 3,000 psi? All right, now we have here the mean. This is really important. We're looking for the average 28-day strength. And I didn't say it, but let's assume here, I'll fix this up after, assume we want this at a 95% level of confidence, because we do need to know what we need here. And down below here, so the key word here is that we want the average 28-day strength. And down here we're told, suppose we have one concrete sample, one, and it has a 7-day strength of 3,000 psi. Before it cures completely, what do we predict at a 95% confidence level that its 28-day strength will be? Now, in answering these two questions, because they're going to be done at the same time in Minitab, this one has to do with a confidence interval, and don't get too worried about the word confidence, but confidence interval is an interval on a mean in this context. Whereas down here, because we're only talking about one concrete cylinder, the difference here is that we want a prediction interval. Now, my prediction interval can still be done at a certain level of confidence, and in this case it's 95. Alright, so we're going to go back to Minitab and get these answers. And in order to do that, we have had to already have put something in the fit regression model, which we already did. Once you have something in here, we gave Minitab the X and the Y. We come down here to the predict line, and we want to plug in, and I'm just plugging in an individual value. I could plug in a whole column, but I only got one number here. And in both parts A and, or sorry, part whatever, one part's asking me for a confidence interval, the other one's asking me for a prediction interval, and they're both based on 3,000 psi for the 7-day strength. You can go to options and you can specify the level of confidence, and we want a two-sided interval. Now, I'm not going to do anything else. I'm just going to say OK. And this is the information that we want, and I'm going to copy and paste this back into my Word file, and we'll talk about it. Alright, now, my confidence interval. So Minitab says to me, if I plug in 3,000 into this equation and do all the calculations, then I'm going to be 95% confident that the average, the mean, the average 28-day strength of all concrete samples that have a 7-day strength of 3,000 psi, that the average 28-day strength is going to be this one right here, between almost 4,500 to 4,910 psi, whereas the prediction interval is right here, and that answers the last part of this question. For this prediction interval, I can say, whoops, I don't like that color, that's way too bright, I can't see it. Let's try that again. Let's go blue. Okay, I can say I'm 95% confident that the 28-day strength of this one particular concrete sample we'll have a 28-day strength that falls somewhere between 4,047 psi up to 5,363 psi. So that's the difference in those two intervals. Alright, I'm going to finish this off, post these videos, and that's it for this semester. Woohoo!